Welcome to this month's episode of Math Learning Hooks. Today we will discuss strategies to activate prior knowledge and to build content knowledge. Our first strategy is called a word recognition chart. Academic vocabulary is essential to true conceptual understanding in math. And to the majority of our students, math is a foreign language. Therefore, we must explicitly teach academic vocabulary in context to our students. The standards for mathematical practice also recognize the importance of a strong academic vocabulary. As students are mastering the practices, they will have to make sense of problems, construct arguments, and attend to precision, which all require an understanding of appropriate academic vocabulary. Academic vocabulary in math is typically addressed by word walls, looking up a list of words in the glossary, or a definition given in the notes by the teacher. Word walls can be effective when used appropriately, but the other two methods are ineffective in getting students to conceptually understand academic vocabulary. A tool that teachers can use to help students with academic vocabulary is the word recognition chart. This chart can be used during a pre-lesson and throughout the unit. When creating the chart, I first refer to my standards. I read over the standards in my unit and I identify 9 to 12 key vocabulary words for student understanding. I then enter one word per box with an example for the students to see. And at the beginning of class, at the beginning of a unit, I'm going to move quickly through the words by following these steps. So first, I'm going to say the word and point to the word. The students will then repeat the word, and then I will give a brief description. So let's look at a math example. So let's say it's the beginning of the school year, I'm doing my lesson planning, and my first unit is relationships between quantities and reasoning with equations. I've read my standards and I've chosen these 9 words. So when I do this, I'm going to point to the word and say the word expression. Then I have the students repeat expression. Then I give a brief explanation. An expression is a mathematical phrase. It does not have an equal sign while pointing to the example. Then I say equation. Students repeat. And then I say an equation is a mathematical sentence. This one does have an equal sign. And so on. And you move through the different words very quickly. This should only take 3 to 5 minutes at the beginning of a unit. Then, throughout the unit, you can refer to this chart to continue to build that academic vocabulary and building that academic knowledge, content knowledge. Post the chart in the room so that all students can see and read it. Then, anytime you or a student use the word in an explanation, point to that word. This allows the students to continue to build a connection between the word, example, and the definition. This is essential. This is so very important for our ELL students. And since most of our students in math are language learners, this will help them build their conceptual understanding. It is important that we do these steps. Another tool that you can use to activate prior knowledge is informal webbing. In math, when we use a graphic organizer, typically we give the students an already formatted web because we, in our minds, know what connections we want them to make. In informal webbing, give the students a topic, a graph, a chart, etc., and have them brainstorm everything they can about it. Then, let the students organize their thoughts into relationships that make sense to them. And of course, as a teacher, you're going to be asking questions to have them explain their reasoning. This can be done in several ways. You can use sites like Real-Time Board, sticky notes, just writing on the board, note cards, etc. Let's say I'm introducing linear systems of equations to my students, and I want to know what they already know regarding linear equations, linear functions, etc. So I find a picture of a linear system, and I place it on the board, and I give them 3 to 5 minutes individually to brainstorm. everything that they can know about this picture. One idea per sticky note, per share out, whatever. Then I let them get with a partner, combine any ideas that they may have, and then we begin grouping putting the sticky notes and the ideas on the board. So for example, these are some things that they could have come up with. Granted, not an exhaustive list. So then, as you're talking with the students, you begin to form this web and things and how they're all connected. And eventually you may end up with a graphic something like this. Again, each class period's web may look different considering the connections that they make and how they see the relationships between the things that they brainstormed. Our final strategy today is a silent tea party. Now, this one is a little bit more challenging to fit into a math classroom. However, you can adapt it to different ways to make it work in the classroom. For an example, one adaptation is to give each student one of these 4 representations of a function or an equation or an inequality. So you have algebraic, verbal, tabular, graphical, the rule of 4. So give each student one of those 4 with different problems. Then the students, without talking, have to communicate and find the other 3 people that go along with theirs. So if I have the verbal, Jose purchased X sodas for $3 each, I need to find the 3 other people that have the algebraic, the tabular, and the graphical representation. This is just a quick way to kind of implement the silent tea party to help with building that academic understanding, that content knowledge. Thank you so much for your time. In the future, I really would like to be able to show some classroom examples of our learning hooks and our strategies. So if you are interested in volunteering to let me video for some of our upcoming learning hooks, please email me. Thank you so much. Have a great day.